Hey everybody, welcome back. Hopefully everybody had an awesome New Year's and Christmas, and we're ready to get back into it. In this video, we're going to be doing kind of an introduction into polynomial functions. And so we're just going to kind of get an idea for what these functions look like. Now, what you're seeing here on the screen, you may want to screenshot this or pause it and write it down into your notes, because this is going to help us solve a lot of different problems. And I know right now you don't know what the degree is, or maybe you may not even know what the leading coefficient means. I'm going to show you all that here in a minute. But for now, just know that if we have an odd degree and a positive leading coefficient, we're going to get a function that kind of looks like this right here. And if it's odd and negative, we'll get something over here. So that's kind of the basic idea. So we'll refer back to this here in a little bit. Let's go ahead though and take a look at some problems, so we can see kind of how we can work with polynomial functions. So you'll see here that we're supposed to find from the equation, or from the rule, we're supposed to find the degree, the type, and the leading coefficient. So I can kind of explain to you real quick what that means, what all this means. Degree is simply going to be the largest exponent. So for number 1, the degree is 4. You can see that the largest exponent is a 4. So we will say that our degree is 4. And then it also says to name the type. You can see right here it tells us to name the type. The type is just the name of function, the name of the polynomial function that we're looking at. And it's based on the degree. Now, if you don't know what that is, you can always Google it. You can always say, what kind of function has a degree of 4? And if you do that, you'll see that a function with a degree of 4 is called a quartic. Quartic function. And I'm writing with my mouse again, guys, so honestly I'm going to move the speaker over here so maybe y'all don't hear me clicking as much, so maybe it won't be quite as annoying. Alright, but the type is just based on the degree. You know some of them, if it's x squared, then that one would be quadratic, like this one over here. If the degree is a 2, then that one's quadratic. If the degree is a 1, like this one right here, this one right here, the degree is a 1, there's a little imaginary exponent of 1 up there, then that's called a linear function. So linear, quadratic. If it's 4, it's quartic. If it's 3, it's called a cubic function. So those are the kind of basic ideas. And you'll have to ignore the bell. The bell's about to ring, guys, and that's just when I'm recording this video, so just ignore it here in a minute when it goes off. All right, and then finally it says to find the leading coefficient. Leading coefficient. That's just the number that's in front of the x that has the degree on it. So for number 1, the leading coefficient would be the number that's in front of the x to the 4th, whichever has the largest exponent. Whichever x has the largest exponent, it's just the number in front of that. So the leading coefficient would be a -3 for number 1. -3. Okay, so degree is the exponent. The type is just the name of the function based on that exponent. And then the leading coefficient, told y'all, there's that bell. Wait for it. All right. Leading coefficient is just the number out front, in front of the x with the largest exponent. Okay, so all these 3 things all come from that one term that has the largest exponent. So if you were working number 2, which I'll let y'all do for practice, if you're working number 2, then the degree and everything would come from the x cubed, because that's the one that has the largest exponent. Now we do have to backtrack here because we missed something. Notice that the question says, decide whether the function is a polynomial function. So backtracking to that, is a function a polynomial function? Here's how we can decide this. If all of the exponents for your x's are integers, then it's a polynomial function. So like number 1, we have a 2, a 4, and this one would be a 1. So that's a polynomial function because all of the exponents for your x's are all integers. However, if we look at number 2 right here, this one down here, or I should say not just integers, but they have to be whole numbers. Okay, your exponents have to be whole numbers. So for example, this one down here would actually be, because it's in the denominator, because your x is in the denominator, it's going to be x to the minus 1. X to the minus 1. Anytime you have an x in a denominator, the exponent's going to be negative. And so since that x is in the denominator, this is not a polynomial function. It's not a polynomial function. If we looked at number 3, this one is, because x to the 1 is, that's legal, that's valid. It doesn't matter what number's out front. Doesn't matter what number's out front. It just matters the exponents on the x. Number 4, we have a 2 and a 1. That one's fine as well. The only things you would probably look out for is where x's are in denominators, like right here, or anytime you'd have the square root of an x. If there was an x inside a square root, that would also be a problem where you wouldn't have a polynomial function. Now you might be looking at this one saying, well, why is this one right here, why is that one why is that one a polynomial function? Well, notice the x isn't underneath the radical. It's out to the side. Okay, the only time when it's a problem is when the x is underneath the radical sign. All right, let's move on and take a look at some different problems. For numbers 5 and 6 here, evaluate the function for the given value. This is very simple, guys. You're just going to take the number that they give you, in this case 2 for x, and you're just going to substitute that in for x and evaluate. Let's work number 6. People always complain, they always work the easiest one, so let's go with number 6 and we'll just solve this one out. So we're going to take negative 4 and we're going to substitute it in for x. So we're going to have negative 4 to the 4th. Negative 4 to the 4th. We're going to have minus 32 times negative 4 squared. And a good practice, guys, is to always put your substitutions into parentheses, and that'll just keep you straight. And then you can just type that directly into your TI-83 or TI-84, and that should give you an answer. Again, remember, always put your substitutions in parentheses. That'll just save you some heartache, potential heartache. All right, but if we do that, then we get an answer of 0, actually. This comes out to be 0. All right, so I'll leave number 5 for you to work, but that's all you do is just take whatever x is, substitute it in, and see what the function evaluates to. But for number 6, we just got 0 as an answer. All right, let's look at the next few. 7 and 8 says, describe the end behavior of the graph of the function. Now for this, we want to look at the term with the largest exponent, so the degree. So for this one, we're just looking at this term right here, and this will tell us everything we need to know about the function. I'll leave number 7 for y'all to do, and we'll look at number 8. So number 8, which one has the largest exponent? We can see this is a 1, 5, 3, and 0. So we're going to go with this one right here. This has the largest exponent. So we're going to take this term, and this will help us describe the end behavior. So we can look back at our graph, and two things we're going to be interested in is the leading exponent. Notice that the leading exponent for this is positive, so we have a positive leading exponent. And also notice that we have an odd degree, so the degree is odd. So we have a positive exponent and an odd degree. So if we look back at our table that we were looking up above, we can see if we have an odd degree and a positive leading coefficient, then our graph is going to kind of look like this. And we're interested in the end behavior. In other words, as we move to the right, what does the function do? And we can see it goes up towards positive infinity. And as we move to the left, what does it do? And we can see that it goes down to negative infinity. You're just looking at what the f of x, what is the function doing? What is f of x doing? F of x is going to positive infinity as you go to the right, and negative infinity as you go to the left. So the answer for this, you could just copy this down. You could say f of x goes to positive infinity as x goes to positive infinity, and f of x goes to negative infinity as x goes to negative infinity. So those are your answers. So for those problems, guys, just refer back to this table and take your answers right off of there. And you'll get your answers based on the degree and the leading coefficient. So remember, both of those things you get from whichever term has the largest exponent. So x to the 5th, largest exponent, 5 is odd, and the leading coefficient here is positive 3. So we have positive and odd. So looking at this one's kind of going in the opposite direction. If we have a graph that kind of looks like this, it says describe the degree and the leading coefficient of this polynomial function. So this is kind of going in reverse. Let's go look at which graph looks like this. So notice we start out up high, do a little zigzag, and then we're going down low on the right side. So upward on the left side, downward on the right side. If we go up and, check our table, it looks like this one is the one that most closely imitates that. It's going upward to the left, downward to the right. I think that was right. Was that correct? Yeah. Downward to the right, upward to the left. Oops. Downward to the right, upward to the left. So we can, it said to describe the degree and leading coefficient, so we can just copy this part right here. The degree is going to be odd, and the leading coefficient is going to be negative. So really easy problems, guys. Refer back to this table. If you need to, remember, screenshot this table or copy it down into your notes. That way you'll be able to refer back to it on the test and be able to get those answers correct. Anyway, guys, I'm going to leave the video off for there. If you have any questions, feel free to leave a comment or send me a message, and I'll get back with you as soon as possible. Y'all have an awesome afternoon, and I will see you later.